is every single IPv4 address usable? Meaning, can I assign them to end stations? Well, first and foremost, you can only assign class A, B, and C addresses to your end stations. You can't assign class D or class E addresses. However, within those class A, B, and C networks, there are reserved IPv4 addresses. The first one is the network address. What is the network address? Well, the network address is the network ID. So if you're thinking about it from a street name versus street number perspective, well, there is the very first address in your grouping of IPv4 addresses for a network that is reserved as the network address, the name of your street. So it's a combination of the network portion and the host portion all combined together, all 32 bits saying, hey, this is the network. And this number is extremely important because it's what our routers utilize to ultimately determine where the various networks are within the organization. So we cannot assign this address to an end station because this address is representing the entire network. It's representing absolutely everybody that lives in that network. And routers use it for forwarding decisions. The way you can identify a network address is that the host portion of the network address, the host portion, is going to have all binary zeros. All binary zeros. So if you had a class A address, then the network portion of that class A address would be the first 8 bits. And then the last 24 bits of that address would be all zeros, and that would be a network ID. If you had a class B address, the first 16 bits would be the network ID, but then the host portion would be all zeros. All zeros. So the last 16 bits would be all zeros, and that's your network ID. And then your class C, the first 24 bits are the network portion, and then the last 8 bits represent the host portion. In this case, it's all zeros because the whole thing is our network address. So anytime you convert an IP address to binary, if that host portion is all zeros, just the host portion is all zeros in that address, then you're dealing with a network address. And it's the network ID for that network, and you cannot assign it to end stations. Now, we also have a directed broadcast address. This is the very last IPv4 address in the network. So we have a network ID, which is the very first address you can assign to end stations. And then you have a directed broadcast address, which is the very last address. How can you identify a directed broadcast address? Well, in binary, the host portion is all ones. So the network address has all zeros in the host portion, and the directed broadcast address would have all ones. So by default, if you have a class A address, your network portion would be the first 8 bits. If the last 24 bits were all 1, then you're dealing with the directed broadcast address. For the class B address, the first 16 bits are the network portion. If the host portion is all 1, so the last 16 bits is all 1s, then you got the directed broadcast address. And then lastly, for the class C, you have 24 bits for the network portion. And in the last 8 bits, if they're all 1s in the host portion, then you're dealing with the directed broadcast address for that particular network. So what's the point of a directed broadcast address? Well, the directed broadcast address allows anybody outside of your network to communicate with everybody inside of your local area network. So in this example here, we have our local area network, which is right here. Right here. So what is the very last address for this local area network? Well, the very last address we're indicating here happens to be 10.255.255.255, which would be the default directed broadcast address of our Class C address of 10.0.0.0, our network. So if our network ID was 10.0.0.0/8, that's the default Class C, the default Class A network address. That's our directed broadcast address in this case. So this directed broadcast address allows devices outside of the local area network to talk to everybody inside our local area network. Everybody. So notice how we have that packet that comes in that's destined to .255.255.255. The router takes it, forwards it, and then it gets flooded absolutely everywhere inside the local area network. Now, this behavior has been disabled by default. Let me point that out to you. It's been disabled by default. Our routers will not forward directed broadcast addresses. So if all of a sudden a packet arrives at our router by default that's destined to the directed broadcast address, it drops it. Why is that? To prevent attacks from happening. Think about what we could have happen here. We could have a malicious PC, malicious user, malicious device send an excessive amount of information into this network that gets flooded to absolutely everybody. Could do that, causing a denial of service attack, flooding our network. We, at one point, had a very specific attack called a Smurf attack. That's right, a Smurf attack that was utilizing this directed broadcast address. So what would happen is, let's say this is our malicious user up here. Malicious user. This malicious user wanted to hurt this device down here. This one right here. So how do we hurt that device? How do we cause a denial of service attack? Well, what we could do is we could send traffic over here to the directed broadcast address of 10.255.255.255. But source it, spoof the packet from this PC here. So pretend it's coming from this PC. So the destination is 10.255.255.255, but the source is actually this PC. And so what'll happen is we send a request in here, and then all these devices respond back to this device down here, and then we've caused a denial of service attack on the device in the bottom right-hand corner. That was a Smurf attack. So to stop that, they said, well, why don't we just prevent directed broadcasts from being forwarded? So if you need them to be forwarded in your organization for some reason, you'll have to turn that feature on your routers. But by default, it has been disabled to prevent that Smurf attack from happening.